In September 2025, NASA held a press conference and said 6 words that had never been spoken by any space agency in history. The closest we have ever come to discovering life on Mars. The rock they found had leopard spots, minerals that on Earth are only made by living things. Organic molecules, a chemical signature that screamed biology. They sealed the sample in a titanium tube, named it Sapphire Canyon. And then 4 months later, Congress cancelled the mission to bring it home. 33 sample tubes, the most important scientific cargo ever assembled on another world, sitting in the Martian dust, with no ride home. But here is what nobody at that press conference said out loud. Mars was not habitable for a weekend. Mars had oceans, rivers, a magnetic field, a thick atmosphere, volcanic energy, and 1 billion years of conditions identical to the ones that produced life on Earth. We needed less time than that to go from bacteria to civilization. So the question is not whether Mars had microbes. The question is what else it had, and whether the reason we cannot find it is because whatever destroyed it was so complete that after 3.5 billion years, only whispers remain, a face carved into a mesa, isotopes that match nuclear test sites, methane rising from underground in seasonal pulses, like breathing. Tonight, we follow the evidence to the most dangerous question in science. What if something lived on Mars, something that built, something that thought, something that died? And what if Mars is not just a dead planet? What if it is a warning? If you enjoy our calm nighttime journeys, remember to like and subscribe. We highly encourage our community to discuss the video topics in the comments and react to other comments. It is the most fun when we share our thoughts. Now, let us begin. Tonight we are going somewhere. Most documentaries will not take you, not to the edge of the universe, not to the bottom of the ocean, but to the surface of a dead world just 55 million miles from where you are lying right now. A world that once had blue oceans and thick clouds and rivers cutting through valleys under a warm sky. A world that looks so much like what Earth used to be that if you visited it 4 billion years ago, you might not know which planet you were standing on. We are going to Mars, but not the Mars you have been told about. Not the dead, dusty, frozen rock. Tonight we are going to follow a trail of evidence that starts with a rock the size of a dinner plate found in an ancient riverbed and ends with a question so unsettling that most scientists will not even say it out loud. What if something lived there? Not bacteria, not slime, something that built, something that thought, something that looked up at the stars the same way we do. And what if the reason we cannot find them is not because they never existed, but because whatever destroyed them was so complete, so absolute, that after 3.5 billion years of wind and radiation and silence, there is almost nothing left. Almost. We are going to look at a rock that NASA called the closest we have ever come to discovering life on Mars. We are going to examine a face carved into the Martian surface that launched 50 years of conspiracy and debate. We are going to hear about isotopes that match nuclear test sites on Earth, found in the atmosphere of a planet where nothing should be detonating anything. We are going to listen to stories written 6,000 years ago by the first civilization in human history. Stories about beings who came from the sky. And at the end of it all, we are going to ask the hardest question of all. If Mars is a graveyard, are we next? Chapter 1. The rock that changed everything. On July 21st, 2024, in a dry riverbed inside a crater called Jezero, a 6-wheeled robot the size of a small car rolled up to a rock and changed everything. The robot was NASA Perseverance rover. The crater was an ancient lake bed, a place where water once poured through a river valley 400 meters wide and pooled into a body of water that may have persisted for millions of years. And the rock, a reddish slab about 1 meter long and half a meter wide, partially buried in the sediment of that ancient river, had something on its surface that nobody expected to find. Spots. Dark spots surrounded by lighter rings scattered across the stone like the markings on a leopard. The science team called them leopard spots. And when they pointed their instruments at those spots, when they used the planetary instrument for X-ray lithochemistry and the scanning habitable environments with Raman and luminescence for organics and chemicals, what they found made them go quiet. The spots contained iron phosphate minerals, specifically a mineral called vivianite and another called greigite. On Earth, these minerals are overwhelmingly associated with one thing: biology. Microorganisms produce them. Living things create them as byproducts of their metabolism. The chemical reactions that form vivianite and greigite in terrestrial rock are driven by microbial activity, by tiny organisms feeding on iron and phosphorus in wet, oxygen-poor environments. The rock also contained organic molecules, carbon-based compounds, the building blocks of life as we understand it. And white veins of calcium sulfate running through the stone confirmed that water had once flowed through it, saturating the rock, creating exactly the kind of environment where microbial life thrives on Earth. NASA named the rock Cheyava Falls after a waterfall in the Grand Canyon. They drilled into it and extracted a core sample, sealed it inside a titanium tube, and labeled it Sapphire Canyon. Then they set it down on the Martian surface. And for over a year, they said almost nothing. 14 months of silence, 14 months of analysis, peer review, internal debate. Then on September 10th, 2025, NASA called a press conference. Acting NASA Administrator Sean Duffy stood at the podium and said words that had never been spoken by any space agency official in the history of human civilization. This is the closest we have ever come to discovering life on Mars. The peer-reviewed paper was published the same day in the journal Nature. The scientists reported that they had found no strong evidence for any non-biological explanation for the leopard spots. Every alternative they tested, every abiotic pathway they modeled, fell short. The spots, the minerals, the organic molecules, the chemical gradients, they all pointed in one direction, toward biology, toward life. They were careful. They used the word potential. Potential biosignature. They did not say, this is proof of life. They said, this is what life looks like when you find it in rock that is 3.5 billion years old. And they said, we need to bring this sample home to know for certain. NASA had even built a scale for this moment. The Confidence of Life Detection Scale, a 7-point framework designed to measure how close any given finding comes to confirming extraterrestrial life. Cheyava Falls landed on that scale. Not at the top, not yet, but higher than anything before it. Higher than anything found on any world, any moon, any asteroid, in the history of space exploration. The sample is still there. Right now, as you listen to this, a titanium tube containing what might be the most important scientific discovery in human history is sitting in the dust of Jezero Crater, alone, waiting. Because in January 2026, the United States Congress effectively cancelled the Mars Sample Return Program. The $11 billion mission that would have sent a lander to Mars, retrieved the tubes, launched them into orbit, caught them with a European Space Agency orbiter, and brought them back to Earth was defunded. 33 sample tubes already filled, the most significant scientific cargo ever assembled on another world. And no ride home. China, Tianwen. 3 mission aims to launch in 2028 and return samples by 2031, but from a different location entirely. The European Space Agency considered repurposing their Earth return orbiter for a solo mission, but in March 2026, ESA member states voted to cancel that too. The Cheyava Falls sample may sit on Mars for decades, It may sit there forever. And here is the part that should keep you awake tonight. Even though this is a sleep documentary, the scientists who studied that rock, the ones who wrote the Nature paper, the ones who spent 14 months running every test they could think of, they were looking for microbes, single-celled organisms, bacteria, the simplest forms of life imaginable. But Mars was not habitable for a weekend. Mars had liquid water, a thick atmosphere, volcanic energy, and a magnetic field for over 1 billion years. Earth needed roughly the same window to go from single-celled life to complex organisms. The conditions were there, the time was there, the chemistry was there. So the question nobody at that press conference asked out loud, the question that hangs over every Mars mission like a shadow, is this: what if the rock does not just contain bacteria? What if Mars had 1 billion years of habitability and something more complex arose? Something that built, something that thought, something that vanished so completely that after 3.5 billion years of erosion and radiation and dust storms, the only trace left is a pattern of spots on a rock in an ancient riverbed, a whisper, a fingerprint, and we just found it, but we are not going to pick it up. That is where we are starting tonight, with a rock that might contain the answer to the oldest question our species has ever asked. Are we alone? And with the disturbing possibility that we already found the answer and then walked away from it. But the Cheyava Falls rock is not the only evidence. It is not even the most disturbing evidence. Because before we can understand what might have lived on Mars, we need to understand what Mars used to be. And what Mars used to be will change the way you think about every planet in the solar system. Because 4 billion years ago, Mars was not a dead world. It was a blue one. Chapter 2. The planet that was our twin. 4 billion years ago, if you could have flown through the inner solar system, you would have seen something that would have stopped you cold. 3 blue worlds, Venus, Earth, and Mars. All 3 rocky planets. All 3 with atmospheres. All 3 with liquid water on their surfaces. All 3, as far as we can tell, habitable. We live on the one that survived. Venus boiled. Mars froze. But for a window of time that lasted over 1 billion years, Mars was not just habitable, it was practically Earth. Scientists call this period the Noachian epoch, roughly 4.1 to 3.7 billion years ago. During this time, Mars had a thick carbon dioxide atmosphere that created a greenhouse effect warm enough to keep water liquid. It had rainfall, actual rain falling from Martian clouds onto Martian mountains and running down into Martian valleys. We know this because the valleys are still there, carved into the southern highlands, branching and winding in exactly the patterns that flowing water creates. Not lava channels, not tectonic cracks, river valleys. Mars had lakes that filled craters and persisted long enough to deposit thick layers of sediment. Jezero Crater, where Perseverance found Cheyava Falls, was one of these ancient lakes. A river poured into it through a gap in the crater wall, carrying sediment that fanned out into a delta. That delta is still visible from orbit, a frozen snapshot of a living hydrological system that operated for millions of years. But the water story on Mars is bigger than anyone realized until very recently. In January 2026, researchers published a study showing that roughly 3 billion years ago, an ocean the size of Earth's Arctic Ocean covered nearly half of the Martian surface. This was not a hypothesis based on models alone. China's Zhurong rover, which landed in Utopia Planitia in 2021, detected ancient beach deposits, shoreline features, sedimentary layers consistent with wave action. Not puddles, not seepage. A sea with beaches and tides and currents. And a NASA-funded study published in the Proceedings of the National Academy of Sciences extended the timeline even further. Mars' habitable period lasted 500 million years longer than previous estimates, stretching well into the late Hesperian age. The planet did not just have a brief wet phase, It had an ocean that persisted for geological ages. But here is what makes Mars truly extraordinary. When the surface began to dry, the water did not simply evaporate into space. It went underground. In November 2025, researchers from New York University Abu Dhabi published findings showing that ancient sand dunes in Jezero Crater had been lithified, turned to stone. By interacting with subsurface water long after the surface had dried, Mars transitioned from wet to underground wet. It built a hidden plumbing system. And then in August 2024 came the discovery that changed everything. Scientists analyzing seismic data from NASA retired InSight lander found evidence of a massive liquid water reservoir buried between 11.5 and 20 kilometers beneath the Martian surface. The water is trapped in tiny cracks and pores in fractured igneous rock in the middle of the planet crust. And there is a lot of it, enough to cover the entire planet in an ocean 1 to 2 kilometers deep. That water is there right now, not ice, liquid water, sitting in the dark beneath the Martian surface at this very moment. Michael Munger, a professor of Earth and planetary science at the University of California, Berkeley, and a co-author of the study, put it simply, "I do not see why the underground reservoir is not a habitable environment." Then, in April 2025, a second study published in the journal National Science Review confirmed the finding using independent seismic analysis. This study placed the water even shallower, between 5 and 8 kilometers deep, and estimated even larger volumes, enough water to flood the entire surface of Mars to a depth of over 500 meters. 2 independent teams, 2 different analyses, same conclusion. Mars has oceans of liquid water right now, just not where you can see them, and it gets stranger. In February 2026, researchers reanalyzing decade-old samples from the Curiosity rover discovered complex organic molecules that had been missed the first time around. Using new thermal extraction techniques, they found long carbon chain molecules, decane, undecane, dodecane, buried in sediment from an ancient lake bed. These are the kinds of molecules that on Earth are associated with biological processes. They had been sitting in the data for 10 years. Nobody noticed until someone looked again with better tools. And then there is the methane. Since 2012, Curiosity has repeatedly detected methane in the Martian atmosphere. The background level hovers around 0.4 parts per billion, but it fluctuates. It peaks in the Martian summer, it drops in winter, and occasionally, without warning, it spikes to 20 parts per billion, 50 times the background level, and then vanishes. On Earth, 95% of atmospheric methane comes from living organisms. The seasonal pattern on Mars mirrors exactly what you would expect from a biological source. Something producing more gas when it is warm, less when it is cold, like breathing. A 2025 study questioned whether Curiosity methane readings are even reliable, pointing to potential instrument contamination from the rover-owned systems. But the seasonal pattern remains. Even if the absolute numbers are off, the relative changes, up in summer, down in winter, are harder to explain as instrument error. And a 2019 methane spike was independently corroborated by the European Space Agency, Mars Express Orbiter. Something on Mars is producing methane. It comes from underground. It follows seasons. And the only explanations are geological processes that nobody has been able to fully model or biology. So let us put it together. Mars had oceans for over 1 billion years. It had rivers, lakes, rainfall, and a thick atmosphere. It had organic molecules. It had energy from the largest volcanoes in the solar system. It had a magnetic field protecting its surface from radiation. It had everything that Earth had when life first emerged here. And right now, today, it still has liquid water underground. It still has methane being released in seasonal cycles. It still has complex organic chemistry locked in its rocks. The question is no longer whether Mars was habitable. That is settled. The question is what happened during that billion-year window, because Earth needed less time than that to go from single-celled organisms to multicellular life. And once multicellular life appeared, the clock started ticking toward complexity, toward intelligence, toward civilization. A billion years is not a weekend, it is an eternity. And Mars had every ingredient. So here is the question that keeps planetary scientists awake at night and that most of them will not say in public. What if we are not the first? What if something arose on Mars during that billion-year window of habitability? Something complex, something aware, something that built and thought and wondered about the stars. And what if the only reason we have not found it is because we have not been willing to look in the right places? Because there is one place on Mars where people have been looking for 50 years. One place where the surface does not look natural. One place where the shapes are too regular, too geometric, too organized to be easily explained by wind and erosion alone. It is called Cydonia. And it started with a single photograph that nearly tore NASA apart. Chapter 3. The Face That Started a War. July 25, 1976. NASA Viking 1 orbiter is circling Mars, photographing the surface, looking for landing sites. The camera sweeps across a region in the northern hemisphere called Cydonia Mensae. It captures frame 035, a 72. And in that frame, staring up from the Martian surface, is something that should not be there. A face, not a vague suggestion of a face. Not a rock that sort of looks like a face if you squint. A massive humanoid face, 2.5 kilometers long, 2 kilometers wide, with what appeared to be eyes, a nose, a mouth, and a headdress, carved into a mesa on the surface of Mars. NASA held a press conference. They released the image. They described it as a huge rock formation which resembles a human head, formed by shadows giving the illusion of eyes, nose, and mouth. They said it would be a good way to engage the public. Then they took a second photograph, 30 days later, from a different angle. Frame 070, a 13. If the face was just a trick of light, why photograph it again? The image detonated. It spread through newspapers, magazines, television broadcasts, and eventually the early internet like wildfire. Books were written, documentaries were produced, entire movements formed around it. Richard Hoagland, a former NASA consultant and science advisor to CBS News, became the face's most vocal advocate. He spent decades analyzing the images, measuring angles, calculating proportions, arguing that the symmetry and geometry of the formation were inconsistent with natural erosion. But Hoagland was not looking at the face alone, because 10 to 20 kilometers southwest of the face, the same Viking photographs revealed something else. A cluster of formations that Hoagland and his colleagues dubbed the City, and at its center, the most geometrically precise formation of all, the D and M pyramid. Named after Vincent DiPietro and Gregory Molinar, the two NASA contractors who first enhanced and analyzed it, the D and M pyramid is a 5-sided structure. Each facet stretches roughly 3 kilometers. The formation rises approximately 1 kilometer above the surrounding plain. Errol Toren, a cartographer employed at the Defense Mapping Agency in Washington, analyzed the geometry of the D and M pyramid and claimed to find mathematical relationships encoded in its proportions. Ratios involving the mathematical constant e divided by pi, the square root of 2. Relationships that he argued were too precise and too numerous to be coincidental. Near the D and M pyramid sat other anomalous formations, a rectangular structure with apparent right angles and straight edges that researchers called the fort, a spiraled mound, what appeared to be buttress walls. Features that, taken together, conspiracy researchers described as an organized urban layout, a city. On Mars, NASA official position was clear: pareidolia. The human brain is wired to see faces and patterns where none exist. We see faces in clouds, in electrical outlets, in the grain of wood. The face on Mars is the same phenomenon scaled up by alien landscape and dramatic lighting. Carl Sagan, perhaps the most famous astronomer of the 20th century, addressed it directly in his 1995 book. He argued that the face was a natural mesa and that the human tendency to see meaningful patterns in random data was the only explanation needed. In 1998, NASA Mars Global Surveyor re-photographed the face at much higher resolution. The new images showed a more eroded, less symmetrical formation than the original Viking photos had suggested. NASA released the images with immediate commentary. It is a natural mesa, case closed. Then in 2006, the European Space Agency Mars Express Orbiter provided the highest resolution three-dimensional images yet. The official verdict held natural formation, erosion and weathering on a mesa in a region of flat-topped hills. But embedded in that same image set were details that the debunking crowd preferred not to dwell on: more geometric features, more pyramid-shaped formations, and a formation that ESA's own team noted was naturally skull-shaped. Natural formations that keep looking artificial. The mainstream scientific response to Cydonia has been consistent for decades. Stuart Robbins, a planetary scientist, published mathematical analyses showing that the geometric relationships Torun and others claimed to find were examples of the Texas sharpshooter fallacy. Drawing the target after the bullets have landed, selecting measurements that fit a desired pattern while ignoring those that do not. The critique is valid. When you have enough measurements to choose from, you can find mathematical relationships in anything. A pile of rocks, a parking lot, the wrinkles on your hand. The geometry argument alone does not prove artificiality, but there is a counter-argument that the debunkers do not address as cleanly. Humans evolved pattern recognition for a reason. Our survival depended on identifying structures, threats, and anomalies in chaotic environments. Dismissing every anomaly as pareidolia is itself a cognitive bias, a bias against recognition. And there is one detail about Cydonia that neither the pattern recognition crowd nor the pareidolia crowd can explain. The face, the D and M pyramid, the city, they all sit in Cydonia Mensae, the same region of Mars where instruments have detected anomalously high levels of xenon-129. Xenon-129 is a stable isotope of the noble gas xenon. It occurs naturally in small amounts. But on Earth, large concentrations of xenon-129 are produced by one process and one process alone: thermonuclear detonation. When a nuclear weapon is detonated in the open atmosphere, it produces a characteristic spike of xenon-129. That spike has been measured at nuclear test sites in Nevada, in Kazakhstan, at Chernobyl, at Fukushima. It is one of the most reliable forensic signatures of nuclear fission, and the concentration of xenon-129 in the Martian atmosphere is unlike anywhere else in the solar system. The ratio is anomalous. It does not match natural volcanic processes. It does not match asteroid impacts. It does not match any standard geological model. And it is centered, according to gamma-ray spectrometer data from NASA Mars Odyssey Orbiter, on two specific locations: Mare Acidalium, approximately 50 degrees north, 30 degrees west, near Cydonia Mensae, and Utopia Planum, approximately 50 degrees north, 120 degrees west, near a region called Galaxious Chaos. Two locations with anomalous nuclear isotope signatures. Two locations with surface features that look less natural than anywhere else on Mars. NASA says the face is a trick of light. The pyramids are natural mesas. The geometry is coincidence. But they have never fully explained why this one small region of Mars has radiation signatures that match nuclear test sites on Earth. The science establishment says pareidolia. The conspiracy world says cover up. And somewhere in between, the data sits there, unexplained, uncomfortable, waiting for someone to take it seriously. And one scientist did. a plasma physicist who spent his career working with NASA and the Department of Defense. A man who looked at the Xenon 129 data and came to a conclusion so extreme, so far outside the boundaries of acceptable scientific discourse, that it nearly destroyed his career. His name is John Brandenburg, and his theory is the most dangerous idea in planetary science. Chapter 4. The Nuclear Hypothesis. Dr. John Brandenburg is not a crank. He holds a PhD in plasma physics. He has worked as a contractor for NASA. He was involved in the Clementine mission to the Moon. He has published in peer-reviewed journals on topics ranging from plasma cosmology to propulsion systems. He presented his research at the Lunar and Planetary Science Conference, one of the most prestigious venues in planetary science. He is a serious scientist who arrived at an extraordinary conclusion, and that conclusion cost him everything. In 2014, Brandenburg published a paper in the Journal of Cosmology titled Evidence of a Massive Thermonuclear Explosion on Mars in the Past. In it, he laid out an argument that would make most scientists recoil. He proposed that Mars was the site of at least 2 massive thermonuclear explosions in the ancient past. Not natural events, not volcanic eruptions, not asteroid impacts, deliberate detonations, weapons. His evidence centered on 3 anomalies. First, the Xenon 129 concentration in the Martian atmosphere. As we discussed in the previous chapter, this isotope is produced in large quantities by nuclear fission, specifically by fast neutron reactions, the kind that occur in open-air nuclear detonations, not in moderated nuclear reactors. Brandenburg pointed out that the xenon isotope mass spectrum of the Martian atmosphere matches the spectrum produced by open-air nuclear testing on Earth. Not approximately, not loosely, matches. He compared the data point by point. The relative abundances of xenon: 128, 129, 130, 131, 132, and 134 in the Martian atmosphere follow the same pattern as the xenon released by atmospheric nuclear weapons tests on Earth. The pattern is characteristic of fast neutron fission, not moderated fission, not volcanic outgassing, not asteroid delivery. Second, surface enrichment of uranium and thorium. NASA Mars Odyssey orbiter carries a gamma-ray spectrometer that has mapped the distribution of radioactive elements across the Martian surface. Brandenburg noted that the concentrations of uranium and thorium are anomalously high in 2 specific locations: Mare Acidalium, near Cydonia Mensae, and Utopia Planum, near Galaxius Chaos. These concentrations are elevated relative to what is found in Martian meteorites, rocks that were blasted off Mars by impacts and eventually fell to Earth. The surface has more radioactive material than the subsurface. Something deposited it there. Brandenburg argued that the pattern is consistent with fallout. Radioactive debris settling on the surface after an atmospheric detonation, concentrated by prevailing Martian winds into 2 distinct zones, downwind of 2 detonation sites. Third, the locations themselves. Both Mare Acidalium and Utopia Planum are in the northern hemisphere of Mars, in the younger, smoother terrain that contrasts with the older, more cratered southern highlands. Both are near regions where surface features have been identified as potentially artificial. The face and the D and M pyramid near Cydonia, anomalous formations near Galaxius Chaos. Brandenburg did not shy away from the implication. He proposed that the detonations were targeted, that they were aimed at populated areas, that they were acts of destruction carried out either by a hostile external force or by the Martians themselves. The scientific response was, predictably, devastating. The Journal of Cosmology, where Brandenburg published his paper, is not considered a top-tier journal by most of the scientific establishment. Critics dismissed the venue before engaging with the content. Those who did engage with the content raised serious objections. The Xenon 129 anomaly, they argued, could be explained by natural processes unique to Mars. Asteroid impacts can produce xenon isotopes through spallation reactions, where high-energy particles knock neutrons out of atomic nuclei. Mars' early atmosphere may have been enriched in xenon-129 through the decay of radioactive iodine-129, which was abundant in the early solar system and has a half-life of roughly 16 million years. The uranium and thorium surface enrichment could reflect volcanic processes, hydrothermal activity, or the preferential concentration of heavy elements by Martian geological processes that we do not fully understand. And the proximity to anomalous surface features could be coincidence. Mars is a big planet with a lot of surface features. If you look hard enough, you can find geometric shapes anywhere. These counter-arguments are reasonable. The natural explanation is simpler. It requires fewer assumptions. It does not invoke an ancient civilization or a nuclear war. By the principle of Occam razor, it should be preferred. But here is what makes Brandenburg work impossible to completely dismiss. Harrison Schmitt, a geologist and the last person to walk on the moon during the Apollo 17 mission, reviewed Brandenburg data and told media outlets that there was general validity to the numbers. Schmitt suggested the nuclear reaction may have occurred naturally over time rather than as a deliberate explosion, but he did not dismiss the underlying isotopic data. Edward McCullough, a space technology consultant, noted reasonable closure between the number of fissions required to produce the xenon-129 enhancement and the amount of energy such events would release. The data, in other words, is real. The xenon ratios are real. The uranium concentrations are real. The surface distribution patterns are real. The debate is about interpretation. And the honest truth is that no mainstream model fully explains all of the anomalies simultaneously. The volcanic model explains some of the xenon, but not the surface distribution pattern. The asteroid impact model explains some of the uranium, but not the xenon spectrum. The early solar system decay model explains the background xenon, but not the localized concentrations. Each explanation covers part of the data. None of them cover all of it. Now, does that mean Brandenburg is right? That Mars was the site of an ancient nuclear war? Almost certainly not. The leap from unexplained isotopic anomalies to deliberate thermonuclear attack is enormous, and the evidence does not come close to bridging that gap. But there is a middle ground that deserves attention. What if the nuclear signatures are real, but the explanation is neither deliberate warfare nor any process we currently understand? What if a civilization existed on Mars and suffered a catastrophe involving nuclear energy? Not a war, an accident, a reactor failure, an experiment that went wrong. Or what if the explosions were natural, a volcanic event or an asteroid impact that happened to produce nuclear-like isotope signatures, and the real mystery is not what caused them, but what they hit? What was at Cydonia and Utopia Planum before the explosions occurred? What was there that is now gone? Brandenburg himself pointed to something that mainstream science has never adequately addressed. The northern hemisphere of Mars, where both anomaly sites are located, is dramatically different from the southern hemisphere. The north is smooth, young, and low in elevation. The south is rough, old, and heavily cratered. This dichotomy is one of the great unsolved puzzles of planetary science. Something resurfaced the entire northern hemisphere of Mars, erasing billions of years of cratering history. The standard explanation is a massive ancient impact or volcanic resurfacing, but the cause remains debated. And the region that was resurfaced is the same region where the anomalous isotopes are concentrated. Brandenburg theory is extreme. It may be wrong. It is almost certainly wrong in its most dramatic claims. But the data behind it is legitimate, and the questions it raises about Cydonia, about the northern hemisphere, about the xenon-129 anomaly, those questions do not go away just because the man asking them went further than the evidence strictly supports, because the data is still there, in the rocks, in the atmosphere, in the gamma-ray maps, waiting. And while modern scientists argue about isotopes and instrument calibration, it is worth remembering that the question of life on Mars is not new. It is not even modern. 6,000 years ago, on the banks of the Euphrates River, the first civilization in recorded history wrote down stories about beings who came from the sky. And some of those stories describe a world that sounds remarkably like the Mars we are only now beginning to understand. Chapter 5. What the Sumerians Knew. 6,000 years ago, in the Fertile Crescent between the Tigris and Euphrates rivers in what is now southern Iraq, a civilization arose that should not have been possible. The Sumerians built cities before anyone else. They invented writing before anyone else. They developed mathematics, astronomy, law codes, literature, and organized religion before any other culture on Earth that we know of. They appeared in the archaeological records seemingly from nowhere, with a language that has no known relatives, no clear ancestor, no linguistic family. Scholars call this the Sumerian problem. Where did they come from? How did they know what they knew? And why does their earliest written literature contain stories so strange, so specific, so eerily resonant with modern discoveries that they still provoke debate 6 millennia later? The Sumerians wrote on clay tablets in a script called cuneiform. Thousands of these tablets have survived, preserved by the very fires that destroyed the libraries that held them. And on those tablets, among the administrative records and the grain inventories and the legal contracts, are stories. Stories about the creation of the world, stories about the origin of humanity, stories about beings who came from the sky. The Sumerians called them the Anunnaki. The word translates roughly as those who from heaven to earth came. According to the texts, the Anunnaki were not gods in the abstract theological sense. They were physical beings. They had bodies. They needed food. They grew tired. They argued with each other. They had hierarchies, rivalries, and agendas. And according to the Sumerians, the Anunnaki came to Earth from somewhere else. They descended from the sky and established cities. They taught humans agriculture, architecture, mathematics, and astronomy. They organized human society and set themselves up as rulers over the people they had either created or elevated from a more primitive state. In 1976, a researcher named Zecharia Sitchin published a book called The 12th Planet. In it, he claimed that the Anunnaki came from a planet called Nibiru, a world on a long elliptical orbit that brings it through the inner solar system every 3,600 years. Sitchin translated the Sumerian texts in ways that mainstream scholars reject. His readings of the cuneiform are widely considered inaccurate by Assyriologists. His astronomical claims about Nibiru have no observational support. His work is not taken seriously by the academic establishment. But the original texts themselves, the ones that predate Sitchin by thousands of years, those are real, and they contain elements that are difficult to dismiss entirely. The Epic of Gilgamesh, the oldest surviving work of literature on Earth, describes a king who travels to the end of the world to find the one man granted immortality by the gods. The Atrahasis epic, dating to roughly the 18th century before the Common Era, tells a story that is even more interesting for our purposes. In the Atrahasis, before humans existed, a class of lesser deities called the Igigi were forced to do the hard labor of the Anunnaki. They toiled in mines, digging, extracting resources from the earth. The work was brutal and unending. After centuries of labor, the Igigi revolted. They refused to work. They burned their tools. They surrounded the dwelling of the chief god and demanded relief. In response, the god Enki proposed a solution. Create a new being, a worker. Mix divine essence with clay and create something that could labor in place of the gods. Humanity, in the Sumerian telling, was engineered as a replacement workforce, created to dig, created to serve, created so that the gods would not have to do their own work. Now, mainstream scholars interpret these stories as mythology, creation myths, Attempts by an ancient culture to explain its own existence and the nature of the universe using the narrative tools available to them. That interpretation is reasonable. Every culture creates origin stories. The Sumerians were no different. But there are details in the Sumerian accounts that create discomfort when you place them next to what we are learning about Mars. The Agigi are consistently described as celestial workers, not Earth-based. They are associated with the heavens, with the sky, with a realm above and apart from Earth. They are distinct from the Anunnaki in their station and their location. Some alternative historians have proposed that the Igigi were stationed not on Earth but on another world, a world closer to the sky, a world that the Sumerians might have understood as a celestial domain, Mars. There is no text that explicitly names Mars as the home of the Igigi. This is interpretation, not translation. But the pattern is provocative. Beings from the sky, stationed in the heavens, forced to extract resources, who eventually rebelled against their masters, on another world. And the Sumerians are not the only ancient culture with stories like this. The Hebrew Bible describes the Nephilim, beings who came from above and interacted with humans. The Inca spoke of Viracocha, a god who arrived from the sky, taught civilization, and then departed. The Dogon people of West Africa have astronomical traditions that describe the Sirius star system with accuracy that Western astronomers did not achieve until the 20th century. And the Mayan creation texts describe what some researchers have interpreted as a star war, a cosmic conflict between celestial factions that occurred in the deep past. None of these cultural traditions prove that Mars hosted a civilization. The connections drawn between Sumerian mythology and Mars are speculative. They rely on interpretation, on reading ancient metaphors through a modern lens, on assuming that mythological language describes literal events. The academic consensus is clear. These are stories, products of human imagination, attempts to explain a mysterious universe. But there is a pattern that the academic consensus does not address as cleanly as it should. Across cultures that had no known contact with each other, separated by oceans and millennia, the same story appears again and again. Beings from the sky, technologically superior, who built monuments, who taught civilization, and who vanished. Every mythology has this thread running through it. Every ancient culture describes a time when the sky people were here and then were gone. And every one of these cultures, when they look up at the night sky, sees the same red dot. The planet that we named after the god of war. The planet that the Sumerians knew. The planet that had oceans and rivers and a magnetic field and 1 billion years to build something. The question is not whether the Sumerians were right about the details. They almost certainly were not. Nibiru does not exist. The Anunnaki, as described by Sitchin, are a product of mistranslation and speculation. But the question that survives all of the debunking is simpler and harder to answer. Why does every ancient civilization on Earth tell the same story about beings from the sky? Is it all coincidence? Is it all imagination? Or is it the faintest echo of something real? Something that happened so long ago that by the time the Sumerians carved their tablets, the memory had already faded into myth. We do not know. But we know that Mars had oceans. We know it had time. We know it had the ingredients. And now, for the first time, we can ask the next question. Not whether something existed on Mars, but what it might have looked like, what it might have built, and how long it might have lasted before everything went wrong. Chapter 6. Building a Civilization on Mars. Let us do something different in this chapter. Let us stop asking whether a Martian civilization existed and start asking what it would have looked like if it did. Not because we have proof, we do not, but because the exercise of imagining it forces us to grapple with the real science of what Mars was, what it had, and what was possible in a billion-year window that we are only now beginning to understand. Start with the basics. What does a civilization need? Water. energy, raw materials. A stable environment that lasts long enough for complex life to evolve and for that complex life to develop intelligence and tool use and social organization. Mars had all of it. Water first. We have already talked about the oceans. An ocean the size of Earth's Arctic Ocean covering nearly half the planet 3 billion years ago. Rivers cutting valleys, lakes filling craters, underground aquifer systems that persisted long after the surface dried. A planet-wide plumbing network that moved water from the surface to the subsurface over hundreds of millions of years. Any civilization needs water. Mars had it in abundance. Energy second. Earth civilizations developed around energy sources: fire, coal, oil, nuclear, solar. Mars had something better than all of those for a world in its early stages: geothermal energy. The Tharsis volcanic complex on Mars is the most extreme volcanic feature in the solar system. It includes Olympus Mons, the tallest mountain on any known planet, standing 21 kilometers above the surrounding plain and stretching 600 kilometers across. Olympus Mons alone is nearly 3 times the height of Mount Everest and wide enough to cover most of France. In June 2025, researchers at the French National Center for Scientific Research published a study proposing that Olympus Mons was once a giant volcanic island rising from an ancient Martian ocean. Imagine that. The largest volcano in the solar system, surrounded by a sea, venting heat from the planet interior into the water and the atmosphere. Geothermal vents on Earth ocean floors support entire ecosystems that thrive without sunlight. Organisms cluster around volcanic vents and build communities powered entirely by the heat of the planet itself. Mars had the same setup, scaled up by orders of magnitude. A civilization developing near the Tharsis volcanoes would have had access to virtually unlimited geothermal energy for as long as the volcanoes remained active. And they remained active for hundreds of millions of years. Raw materials third. Mars' surface is rich in iron. The planet is red because its surface is coated in iron oxide, rust. Beneath that rust lies basaltic rock rich in silicon, magnesium, and aluminum, the kind of materials that on Earth are used to build everything from tools to structures to electronics. Mars' lower gravity would have been an advantage in construction. At 38% of Earth gravitational pull, structures on Mars could have been built taller and more ambitiously than anything on Earth. The engineering constraints that limit building height on our planet, the compressive strength of materials fighting against gravity, would have been dramatically relaxed on Mars. A building that would stand 10 stories on Earth could theoretically stand 25 on Mars. And then there is the land. Mars is smaller than Earth, but its surface area tells a different story. Because Earth is 71% ocean, the total land area of Mars is roughly equivalent to the total land area of Earth. An entire planet worth of solid ground to build on. And that ground includes features that, even through the lens of pure geology, are staggering. Valles Marineris, the largest canyon system in the solar system, 4,200 kilometers long, 7 kilometers deep. If you placed it on Earth, it would stretch from New York to Los Angeles. It is so large that the Grand Canyon would fit inside one of its tributary channels. The conventional explanation for Valles Marineris is tectonic. The crust of Mars cracked and pulled apart as the Tharsis volcanic bulge formed, creating a rift that widened over billions of years. But the feature is also associated with catastrophic water release. Evidence suggests that enormous volumes of water once burst from the eastern end of the canyon system, flooding the northern plains in some of the largest flood events ever documented in the solar system. What if Valles Marineris was not just a tectonic crack? What if it was a feature that was widened by catastrophe? A landscape that was ripped apart by forces that acted on an already developed terrain? Between the Tharsis volcanic complex and Valles Marineris lies a region called Noctis Labyrinthus, the labyrinth of night. It is a maze, a vast network of interconnecting canyons, right-angled walls, grid-like patterns that look from orbit like the ruins of something organized. Planetary scientists describe it as the result of tectonic fracturing combined with the collapse of subsurface material as water or ice escaped from below. The geology is well understood, but the appearance is haunting. Grid patterns, right angles, organized corridors, features that humans tend to build. Now here is the timeline question that makes all of this matter. How long does it take for life to become intelligent? On Earth, the first life appeared roughly 3.8 billion years ago. The first multicellular life appeared about 600 million years ago. The first tool use appeared about 3.3 million years ago. The first civilization appeared about 10,000 years ago. That is a long process. But the critical acceleration happened fast. Once complex animals appeared, once brains started getting bigger, once social organization and tool use began, the transition from stone tools to smartphones took roughly 12,000 years. The window of Mars' habitable period lasted over 1 billion years. That is 3 times longer than the entire span between the first animals on Earth and us. If Mars had even a fraction of Earth biological luck, 1 billion years is more than enough time for evolution to produce complex organisms. Not necessarily humanoid, not necessarily anything we would recognize, but potentially intelligent, potentially aware, potentially capable of building, and the timeline overlaps. Mars, habitable period, and Earth earliest life period were happening at the same time. Whatever was stirring in the warm oceans of Mars was happening while the first organisms were emerging in Earth-own waters. 2 worlds, same solar system, same epoch, same ingredients. If life arose independently on both, it would mean that life is not a rare accident. It is a tendency, a direction the universe wants to go. And if life arises easily, intelligence might follow more often than we think. 1 billion years, an ocean, volcanic energy, mineral wealth, low gravity, an entire planet worth of land. Everything a civilization could need. And we know, because we did it ourselves, that it does not take 1 billion years to go from microbes to cities. It takes less. So the question that every planetary scientist dances around, the question that Brandenburg stated and the mainstream rejected, the question that the Sumerians may have been trying to answer with their stories about beings from the sky, is this: what stopped it from happening? What killed Mars? And the answer to that question begins with a shield, an invisible shield that Mars once had and lost. And when it lost that shield, everything fell apart. Chapter 7. The day the shield died. Right now, as you lie here listening to this, you are being protected by something you cannot see, cannot hear, and cannot feel. It surrounds the entire planet. It extends tens of thousands of kilometers into space, and without it, you would be dead. Everything on the surface of the Earth would be dead. The oceans would evaporate. The atmosphere would be stripped away molecule by molecule until nothing was left but bare, irradiated rock. This invisible shield is Earth's magnetic field. Deep inside our planet, the outer core is a churning ocean of molten iron and nickel. It flows in complex convection patterns, driven by the heat of the inner core. And because it is electrically conductive, and because it is moving, it generates an electric current. That current generates a magnetic field. Scientists call this process the geodynamo. The magnetic field it produces wraps around the Earth like a cocoon, creating a magnetosphere that deflects the solar wind. The relentless stream of charged particles that the sun blasts outward at speeds of 400 kilometers per second. Without the magnetosphere, those particles would slam into the upper atmosphere. They would ionize gas molecules, stripping electrons from atoms, giving those atoms enough energy to escape the planet's gravitational pull. Over millions of years, the entire atmosphere would bleed into space. The water would follow. Life would end. Mars had the same system. 4.2 billion years ago, Mars had a molten core. It had a geodynamo. It had a global magnetic field. We know this because the evidence is frozen into the rock. Ancient Martian rocks, both on the surface and in meteorites that have made their way to Earth, preserve magnetic signatures. Minerals in those rocks crystallized in the presence of a strong magnetic field. The field direction is recorded in the alignment of iron-bearing minerals, locked in like a compass needle frozen in stone. Mars had a shield, and then it lost it. Mars is smaller than Earth, about half the diameter, about 1/10 the mass. And because it is smaller, it radiated its internal heat into space faster than Earth does. The core cooled, the molten iron slowed, the convection weakened, and the dynamo sputtered and died. Research from Harvard, published in 2023, pinned the final collapse of the Martian dynamo to approximately 3.9 billion years ago. Though the field may have persisted in a weakened state, flickering on and off, and even reversing polarity before its final extinction. And here is the detail that makes this story truly cruel. A weak magnetic field is worse than no magnetic field at all. Research published in the journal Astronomy and Astrophysics showed that when a planet magnetic field is dying, when it is too weak to fully deflect the solar wind, but still strong enough to channel charged particles, it actually accelerates atmospheric loss. The weakened field lines act like funnels, guiding solar wind particles into the atmosphere 6 times faster than if there were no field at all. Mars did not just lose its shield. Its dying shield actively helped destroy its atmosphere. It is like a castle gate that breaks halfway open. Instead of keeping the enemy out, it channels them directly into the courtyard. NASA designed an entire mission to watch this process in real time. The Mars Atmosphere and Volatile Evolution spacecraft, MAVEN, entered orbit around Mars in 2014 with one primary mission: measure how fast Mars is losing its atmosphere right now. What MAVEN found confirmed the worst-case scenario. Mars is still losing atmosphere today. The spacecraft detected an ion plume trailing behind Mars, a stream of charged particles being ripped from the upper atmosphere and carried away by the solar wind. Mars has a comet-like tail, a tail made of its own atmosphere, streaming away into space. The last breath of a dying world. Bruce Jakosky, MAVEN principal investigator, has stated that the solar wind stripped Mars' atmosphere and that his team is watching the process happen in real time. During solar storms, when the sun output of charged particles spikes, MAVEN measured atmospheric loss rates increasing by a factor of 10. The sun is still erasing Mars, one particle at a time. In December 2022, MAVEN observed something remarkable and terrifying. During a rare solar event, the solar wind essentially disappeared from Mars' vicinity. For a brief period, the pressure of the solar wind dropped to near zero, and Mars responded. Its magnetosphere, what little remains of it as crustal magnetic fields, ballooned outward by thousands of kilometers. The bow shock, the boundary where the solar wind meets the planet's magnetic influence, expanded dramatically. For a few hours, Mars got its shield back. Then the solar wind returned. The magnetosphere collapsed. The shield was gone again. Now imagine what this would have looked like from the ground. Imagine a civilization on Mars, 3.9 billion years ago, watching the sky change. At first, it would have been subtle. Auroras, appearing at unusual latitudes. Faint shimmering lights in the Martian sky that should not be there. As the magnetic field weakened, the auroras would spread. On Earth, auroras are confined to the polar regions because the magnetic field channels solar wind particles to the poles. On Mars, as the field collapsed, the entire sky would begin to glow. Then the temperature would begin to drop. Not overnight, over centuries, over millennia. The atmosphere thinning, the greenhouse effect weakening, summers becoming shorter, winters lasting longer. The oceans would begin to shrink, slowly at first, then faster, coastlines retreating, lakes drying up, rivers running lower each decade, and the radiation would increase. Without the magnetic field filtering the solar wind, ultraviolet radiation from the sun would reach the surface at intensities that damage DNA. Skin would burn, eyes would suffer, crops would fail. The surface of the planet would become hostile to complex life. But the water would not disappear all at once. The research from New York University Abu Dhabi told us that Mars did not simply go from wet to dry. The water went underground. It seeped into the rock. It filled pores and fractures in the crust. It created a subsurface biosphere, a hidden world of liquid water, insulated from the surface chaos by kilometers of stone. A civilization watching its world die would have had a choice: stay on the surface and perish, or go underground, follow the water, build beneath the rock, retreat into the dark, and hope that the planet would heal. According to InSight data, liquid water exists right now between 11 and 20 kilometers beneath the Martian surface. At those depths, the temperature is warm enough for water to remain liquid. The rock provides shielding from surface radiation. The geothermal gradient provides heat. A civilization could survive underground for millions of years. In theory, but eventually, even the underground would fail. The geothermal heat would diminish as the core continued to cool. The water would freeze in the deeper rock or become locked in mineral matrices. The last habitable niches would close one by one like doors shutting in a hallway. And whatever was living down there would face a final choice. The surface is gone. The underground is dying. There is only one option left: leave. And there was only one place close enough to go. Chapter 8. What destroyed them? The magnetic field died. The atmosphere bled into space. The oceans retreated underground. But that is the slow version of the story, the gentle version. The version where Mars had time to fade, where whatever lived there had centuries or millennia to adapt, to retreat, to plan. There is another version of this story, a faster version, a more violent version, and the evidence for it is carved into the surface of the planet in scars so large they are visible from Earth. Start with the Hellas Basin. It sits in the southern hemisphere of Mars. It is 2,100 kilometers across, 9 kilometers deep. It is one of the largest confirmed impact structures in the entire solar system. Something hit Mars there, something enormous. An asteroid or a comet, large enough to punch a hole in the planet crust that you could lay the distance from London to Moscow inside. The energy released by the Hellas impact would have been beyond anything we have words for. The shockwave would have traveled around the planet. Earthquakes would have rippled through the crust for months. The heat pulse would have set the atmosphere on fire. Debris launched into space would have rained back down across the entire globe, creating a secondary bombardment that would have lasted for days. Dust and pulverized rock thrown into the upper atmosphere would have blocked sunlight for months, possibly years. Temperatures would have plummeted. A nuclear winter without the nuclear. If the Hellas impact occurred while Mars was still habitable, while something was living on that planet, it would have been an extinction-level event. Not a setback, an ending. And Hellas is not the only scar. The Tharsis volcanic complex tells its own story of catastrophe. 4 massive volcanoes, including Olympus Mons, which was active for hundreds of millions of years. When those volcanoes erupted, they did not produce gentle lava flows. They produced floods, catastrophic outpourings of lava that melted subsurface ice and triggered landslides that reshaped entire regions. In 2017, researchers discovered young volcanoes inside Valles Marineris that were only 200 to 400 million years old. Mars was volcanically active far more recently than most models had assumed. And between the Tharsis region and Valles Marineris lies Noctis Labyrinthus, the labyrinth of night. Terrain that collapsed as subsurface water and ice escaped catastrophically, leaving behind a maze of canyons and corridors. The surface literally fell into itself. Volcanic eruptions on Mars would have done more than reshape the landscape. They would have pumped gases into the atmosphere, temporarily thickening it, creating brief warm periods followed by rapid cooling as the gases were stripped away by the solar wind. A cycle of false hope. The atmosphere builds, the temperature rises, life on the surface might begin to recover, then the solar wind tears it away again. And each cycle leaves the planet a little more depleted than before. But the catastrophe question goes deeper than any single impact or any single eruption, because the northern hemisphere of Mars is one of the great, unsolved mysteries in planetary science, the Martian dichotomy. The southern hemisphere of Mars is old, cratered, and elevated. It looks like what you would expect the surface of a 4-billion-year-old planet to look like: battered, scarred, ancient. The northern hemisphere is the opposite. It is smooth, young, low in elevation. The craters are fewer and shallower. The surface has been resurfaced, wiped clean, made new. Something erased the northern hemisphere geological history. The leading hypothesis is a single catastrophic impact event early in Mars history. A collision so large that it melted and resurfaced the entire northern third of the planet. If this is correct, the impactor would have been roughly the size of Pluto. The energy would have liquefied the crust. And everything on the surface in the northern hemisphere, everything, would have been vaporized. Now consider Brandenburg theory in this context. His two proposed detonation sites, Mare Acidalium and Utopia Planum, are both in the northern hemisphere, both in the resurfaced region, both in the young, smooth terrain that replaced whatever was there before. If his nuclear hypothesis is wrong, the coincidence is still uncomfortable. The anomalous isotopes are concentrated in the region of Mars that was most violently resurfaced. If his hypothesis is right, then the resurfacing is part of the evidence, not background geology. So what killed Mars? The honest answer is that we do not know for certain, but we can model the scenarios. Scenario 1. The slow death. The magnetic dynamo fails. The atmosphere thins over hundreds of millions of years. The oceans retreat underground. The surface becomes uninhabitable through gradual radiation exposure and temperature decline. Life retreats to subsurface habitats. Those habitats shrink as geothermal heat diminishes. Extinction by attrition. A long, quiet fading. Scenario 2. The fast death. A massive impact, something on the scale of the Hellas event or larger, strikes the planet while it is already weakened. The atmosphere, already thin, is catastrophically disrupted. Surface temperatures swing wildly, dust blocks the sun. Then the dust settles and ultraviolet radiation floods the surface without atmospheric protection. Underground water systems are disrupted by seismic activity. Habitats collapse. Extinction in thousands of years rather than millions. Scenario 3. The self-inflicted death. Brandenburg hypothesis. A civilization develops nuclear capability. Something goes wrong, whether by war, accident, or experiment. Nuclear events irradiate the surface, damage the remaining atmosphere, and accelerate the collapse that was already underway. The most terrifying scenario because it implies intelligence. It implies that being smart enough to build is not enough to survive. Scenario 4. All of the above. The magnetic field dies. The atmosphere begins to thin. Volcanic eruptions destabilize the surface. An asteroid impact delivers a devastating blow to an already weakened planet. And if a civilization existed, it may have contributed to its own destruction in ways that compounded the natural catastrophes. Each scenario alone could kill a world. Together, they are overwhelming. And here is what haunts the researchers who study this. The evidence on Mars is consistent with all of them, not one catastrophe. Multiple catastrophes layered on top of each other, spread across hundreds of millions of years. Impact, volcanism, atmospheric collapse, possible nuclear signatures, as if the planet was hit from every direction at once. And the thing about that is this: that is exactly what happened to the dinosaurs on Earth. Not one event, a cascade. The Chicxulub asteroid struck. Volcanic activity in the Deccan Traps was already underway. Climate was already shifting. The asteroid did not just kill the dinosaurs. It pushed an already stressed system past its breaking point. Mars may have experienced the same cascade. A planet already losing its shield, already losing its atmosphere, hit by impacts and volcanism in a sequence of blows that left nothing standing, nothing visible, nothing recognizable, nothing except anomalous chemistry in the atmosphere, geometric shapes on the surface, and a seasonal pulse of methane seeping from underground. As if something down there is still breathing. Chapter 9. The methane that breathes. After everything we have just discussed, after the impacts and the volcanism and the atmospheric collapse and the nuclear hypothesis, after all the ways Mars could have died and probably did, here is the part that makes the hair on the back of your neck stand up. Something on Mars might still be alive, not on the surface. The surface is a frozen, irradiated desert where the average temperature is -60 degrees, and the atmospheric pressure is so low that liquid water would boil and evaporate almost instantly. Nothing complex survives on the surface of Mars today, but underground is a different story, and the evidence for something happening underground comes from a gas that should not be there: methane. Since 2012, NASA Curiosity rover has been detecting methane in the Martian atmosphere from its landing site in Jezero Crater. The detections are subtle. Background levels hover around 0.4 parts per billion, a whisper. But that whisper has a pattern. It fluctuates with the seasons. Methane levels peak during the Martian summer when surface temperatures are highest. They drop during winter when the planet cools, and occasionally, without warning, the levels spike. In 2019, Curiosity measured a methane surge of roughly 21 parts per billion, 50 times the background level. It appeared. It lasted briefly. Then, it vanished. On Earth, the situation with methane is simple. 95% of atmospheric methane is produced by living organisms, microbes in wetlands, bacteria in the digestive systems of animals, organisms in ocean sediments. Life makes methane. It is one of the most reliable biosignatures we know. The seasonal pattern on Mars mirrors exactly what you would expect from a biological source. More activity when it is warm, less when it is cold, like a pulse, like breathing. But here is where the story gets complicated. The European Space Agency launched the Trace Gas Orbiter in 2016 with one specific mission: detect methane from orbit using instruments far more sensitive than anything Curiosity carries. The result was shocking. Nothing. Zero. The Trace Gas Orbiter found no methane in the Martian atmosphere. None. How is that possible? How can one instrument on the ground detect a gas that a far more sensitive instrument in orbit cannot see? The leading explanation is that methane on Mars is released in small, localized plumes from underground sources. The gas seeps through cracks in the rock, enters the atmosphere near the surface, and is destroyed by ultraviolet radiation and chemical reactions before it can rise high enough or spread wide enough for orbital instruments to detect. The methane lives and dies close to the ground. It comes up, it is destroyed, it comes up again. A cycle, a pulse. Something beneath the surface is releasing it, periodically, seasonally. And then, in 2025, the situation got even murkier. A study published in the Journal of Geophysical Research Planets questioned whether Curiosity methane readings are even reliable. The researchers pointed to pressure instabilities in the tunnable laser spectrometer, the instrument Curiosity uses to measure methane. They noted that the four-optics chamber of the instrument contains methane concentrations 3 to 4 orders of magnitude higher than the sample cell. In plain language, Curiosity might be smelling its own methane. The most provocative Mars finding of the past decade could be contamination from the instrument itself, but this is not the end of the story. Because even if the absolute values are wrong, the seasonal pattern remains. If the instrument was simply leaking its own methane at a constant rate, you would expect a constant reading. What you would not expect is a reading that goes up in summer and down in winter in perfect sync with the Martian seasons. And the 2019 spike was independently detected by the European Space Agency, Mars Express Orbiter, a completely different spacecraft with a completely different instrument. At roughly the same time and from the same general area, 2 instruments, 2 spacecraft, same signal. The scientific community is genuinely split on this. Some researchers believe the methane is real and biological in origin. Others believe it is an instrument artifact. Others believe it is real but geological, produced by serpentinization, a chemical reaction between water and olivine-rich rock that generates methane without biology. And some believe we simply do not have good enough instruments yet to know. But here is what pushes the needle toward biology, even if only slightly. In February 2026, researchers published findings showing that ancient microbial life could theoretically survive for up to 50 million years, preserved in Martian ice. As long as the ice is clean and not mixed with Martian soil, which contains perchlorates that destroy organic material. 50 million years, not 50 million. The InSight data shows liquid water between 11 and 20 kilometers beneath the surface right now. At those depths, the temperature is warm enough for liquid water. The rock provides radiation shielding. The mineral-rich environment provides chemical energy. On Earth, subsurface biospheres at similar depths contain more microbial life than the entire surface of the planet. Billions of organisms per gram of rock, thriving in total darkness, feeding on chemical energy, completely independent of sunlight. If anything survived the collapse of Mars' surface environment, if any form of life retreated underground as the atmosphere thinned and the oceans dried and the radiation increased, it could still be there. Not fossils, not frozen remnants, living organisms, producing methane, breathing. And here is the thought that connects everything we have discussed tonight into a single thread. If a civilization existed on Mars, and if it was destroyed by the cascade of catastrophes we described in the last chapter, would anything biological have survived? Not the civilization itself, not the intelligence, not the culture, not the technology, but the biology, the microbial substrate, the bacteria and archaea, and whatever equivalents Mars might have produced. The simplest, hardiest, most ancient forms of life, the kind that on Earth survive in nuclear reactor cooling pools and at the bottom of mine shafts and inside Antarctic ice sheets. Could the biological descendants of a Martian civilization still exist? Not as thinkers, not as builders, as microbes, as the degraded remnants of a biosphere that once supported something far more complex. Producing methane in the dark, following the seasons, breathing. We do not know. We cannot know from here. But we know something is producing methane on Mars. It follows a pattern that looks biological. It comes from underground, and the planet that produces it once had everything life needs, everything intelligence needs, everything civilization needs, and lost it all. The methane might be geology. It might be instrument error, or it might be the last heartbeat of a world that once lived, and we are standing just close enough to hear it, but not close enough to understand it, not yet. Chapter 10. The evidence we will never see. Let us now confront the hardest counterargument head-on, the argument that should, by all rights, end this documentary. The argument that says, even if a civilization existed on Mars, we would never find it. Because time destroys everything, and 3.5 billion years is a lot of time. Consider what happens to evidence on Earth. Göbekli Tepe, the oldest known temple complex on our planet, is roughly 12,000 years old. When it was rediscovered in 1994, it was buried under meters of soil and rubble. Without deliberate excavation, it would have been invisible. The Great Pyramid of Giza is 4,500 years old. It is already eroding. The outer casing stones that once gave it a smooth white surface are almost entirely gone, stripped by weather and human scavenging. In another 10,000 years, it will be significantly reduced. In 100,000 years, it will be a rounded mound. In 1,000,000 years, it will be indistinguishable from a natural hill. Now, scale that to 3.5 billion years. No organic material would survive. No metal would remain uncorroded. No glass, no plastic, no composite material. Nothing manufactured would retain its original form. Everything would be broken down at the molecular level, mixed into the surrounding rock and soil, chemically indistinguishable from the geology around it. On Earth, this process is accelerated by plate tectonics. Continental plates move, collide, and subduct, pulling surface material down into the mantle, where it is melted and recycled. The ocean floor is entirely replaced every 200 million years. Nothing that was on the ocean floor more than 200 million years ago exists anymore. It has been melted back into the interior of the planet. Mars does not have plate tectonics. This is actually good news for the search. Without plate tectonics, the Martian surface is not recycled. 2/3 of Mars' surface is over 3.5 billion years old. The planet is a time capsule in a way that Earth is not. Features on Mars have been sitting in roughly the same position for billions of years. But that time capsule has been under siege. Cosmic radiation bombards the surface continuously. Without a magnetic field or a thick atmosphere, Mars' surface receives ultraviolet and ionizing radiation at levels that would sterilize any exposed biology within hours. Over billions of years, this radiation breaks molecular bonds, degrades complex chemicals, and destroys organic compounds in the upper layers of soil and rock. Dust storms, some of which envelop the entire planet for months at a time, sandblast the surface. The fine-grained abrasive dust of Mars acts like slow sandpaper, wearing down features, rounding edges, filling depressions, and burying formations under layers of wind-blown sediment. Impact cratering continues to churn the surface. Every meteor strike excavates old material, buries it under ejecta, and mixes layers that were once distinct. After 3.5 billion years of radiation, wind erosion, impact gardening, and chemical degradation, what would survive of a civilization? Almost nothing physical. No buildings, no roads, no artifacts smaller than a mountain, nothing you could pick up and identify as manufactured. But the key word is almost, because there are categories of evidence that could survive even on these timescales. Large-scale terrain modifications. If a civilization quarried mountains, diverted rivers, built canals, or excavated underground complexes, the large-scale features might persist as anomalous landforms. Shapes too regular to be easily explained by erosion. Geometric patterns in terrain that natural processes do not typically produce. Voids that suggest excavation rather than collapse. Anomalous mineral concentrations. If a civilization mined resources, processed materials, or produced industrial waste, the chemical signature could persist in the rock. Elevated levels of certain elements in localized areas. Isotopic ratios that do not match natural geological processes. Exactly the kind of anomalies that the Mars Odyssey gamma-ray spectrometer has detected at Cydonia and Utopia Planum. Nuclear isotope signatures. As Brandenburg argues, nuclear activity produces isotopic fingerprints that are distinct from natural processes and can persist in a planet atmosphere and surface chemistry for billions of years. The Xenon 129 anomaly in the Martian atmosphere, whatever its cause, is real. Subsurface voids. Tunnels, chambers, bunkers, and other underground structures would be detectable by ground-penetrating radar and seismometry. Rock conducts seismic waves differently than air or water-filled cavities. If artificial underground spaces exist on Mars, our instruments could find them. And here is the uncomfortable truth. This is exactly the kind of evidence that exists at Cydonia. Large geometric shapes on the surface, anomalous nuclear isotope concentrations in the atmosphere, elevated radioactive element concentrations detected by orbital instruments, features that planetary scientists describe as natural messes but that the human eye consistently reads as structures. It is exactly the kind of evidence that could survive 3.5 billion years of erosion. And it is there. But we have never gone to look. No rover has ever visited Cydonia. No sample has been taken from the face or the D and M pyramid. No seismometer has been placed near the anomalous formations to listen for subsurface voids. No ground-penetrating radar has been deployed in the region to search for artificial cavities. In 50 years of Mars exploration, with dozens of missions and billions of dollars spent, not one spacecraft has been sent to investigate the most anomalous region on the planet's surface. Is this because Cydonia is scientifically uninteresting? Possibly. The mainstream consensus is that the formations are natural and that investigating them would lend undeserved credibility to conspiracy theories. But there is another possible reason, a reason that is harder to say out loud but harder to ignore. Confirming artificial structures on Mars would be the most destabilizing discovery in the history of our species. It would reshape every religion, every philosophy, every assumption about human uniqueness and our place in the universe. It would force us to reckon with the possibility that intelligence can arise, build, thrive, and be completely destroyed. That the universe produces civilizations and then erases them. That we are not special. That we are not safe. The Cheyava Falls sample sits on Mars right now, a potential biosignature in a titanium tube, the most important rock in human history. And nobody is going to pick it up. The Mars Sample Return Program is cancelled. The European backup mission is cancelled. The samples sit in the dust, and the questions remain unanswered. The silence is starting to feel less like a budget decision and more like a choice. A deliberate choice not to know, because some answers change everything. And some institutions prefer questions that stay open. Chapter 11. What NASA does not talk about. Let us be clear about something before we go further. This is not a chapter about accusing NASA of running a secret conspiracy. NASA is a scientific organization staffed by thousands of dedicated researchers who genuinely want to understand the universe. The men and women who build rovers and analyze rock samples and stay up all night watching data streams from Mars are not villains. They are explorers. But institutions have patterns, and the pattern around Mars, specifically around the question of what might have existed on Mars beyond microbes, is worth examining. Because the pattern is not one of investigation, it is one of framing. Start with the Viking mission itself. 1976. Viking 1 photographs the face in Cydonia. NASA holds a press conference. They release the image to the public. They describe it openly. For a brief moment, the institutional response is curiosity. This is interesting. Look at this. Then the framing shifts. By the time Mars Global Surveyor re-photographs the face in 1998 at higher resolution, the institutional posture has completely reversed. The new images are released with immediate debunking commentary attached. Natural mesa, trick of light, case closed. Not, here are higher resolution images, let us examine them carefully and see what they tell us. Instead, it is, here is the proof that you were wrong to be interested. The framing is not scientific inquiry, it is narrative management. In 2006, the European Space Agency, Mars Express, provides even higher resolution, three-dimensional imagery of Cydonia. Same verdict. Natural formation, but the images also reveal more geometric features, more angular shapes, more formations that would raise eyebrows if found on any archaeological site on Earth. These are noted in passing and never investigated further. The pattern repeats. Photograph, debunk, move on. Never photograph, investigate, conclude. Always photograph, explain, close the file. And then there is Brian O'Leary. O'Leary was a Princeton physics professor. He was a former NASA astronaut candidate. He was a member of the Mars mission planning team. He was not a fringe figure, he was an insider, and he went public with a claim that rattled the Mars research community. O'Leary stated that Carl Sagan, the beloved astronomer who had publicly dismissed the face as pareidolia, had personally tampered with the Viking photograph of the face before it was released to the public. According to O'Leary, Sagan had the image enhanced in ways that made the face look less face-like, not to clarify the science, to control the narrative. O'Leary expressed deep disappointment. He described a culture within the scientific establishment that was more concerned with managing public perception than with following the data wherever it led. Whether O'Leary's accusation is accurate is debatable. Sagan is not alive to respond. But O'Leary's credentials were real. His access was real. And his willingness to make such a claim publicly, knowing the professional cost, suggests he believed what he was saying. Brandenburg himself is another example of this pattern. A plasma physicist, a NASA contractor, a participant in the Clementine mission to the Moon, a man with legitimate scientific credentials who presented his research at the Lunar and Planetary Science Conference, a mainstream venue. His nuclear hypothesis was extreme. It may well be wrong, but the data he cited, the xenon-129 ratios, the uranium and thorium surface concentrations, the gamma-ray spectrometer maps, that data came from NASA-owned instruments. He was using their data to ask a question they did not want asked. And the response was not to investigate further. It was to marginalize the questioner. This is how institutions protect themselves. Not through conspiracy, through culture, through the unspoken understanding that certain questions are career-ending, that certain lines of inquiry lead to professional exile, that the reward for suggesting that Mars might have hosted more than bacteria is not a research grant but a reputation as a crank. The result is a blind spot, not a deliberate cover-up, a structural inability to look in certain directions. And that blind spot has real consequences. Consider the Mars sample return cancellation. The official reason is cost. $11 billion is too much money. The budget is tight. Priorities must be set. Fair enough. But consider the context. The James Webb Space Telescope cost $10 billion. It went over budget by years and billions. It was funded. The International Space Station costs $3 to $4 billion per year to operate. It has been funded continuously for decades. NASA annual budget is approximately $25 billion. The Cheyava Falls sample contains what NASA own acting administrator called the closest we have ever come to discovering life on Mars. It is sealed in a titanium tube on the Martian surface right now. A peer-reviewed paper in Nature describes it as a potential biosignature. It is the single most scientifically significant object ever collected outside of Earth, and Congress cancelled the mission to retrieve it. The European Space Agency considered repurposing their Earth return orbiter for a standalone mission they called Zefiro. In early 2026, ESA member states voted to cancel that too. Nobody is going to pick up the most important rock in human history. Maybe the reason really is money. Government budgets are complicated. Priorities shift. Politics intervene. There does not need to be a conspiracy for a program to be cancelled. But there is a question that hangs in the air. If the Cheyava Falls sample contained evidence not just of microbial life but of complex biology, of a biosphere with no Earth analog, of something that suggested Mars once hosted more than bacteria. Would anyone want that information public? What would it do to religious institutions that teach human uniqueness as doctrine? What would it do to geopolitics when one nation has proof of alien life and others do not? What would it do to markets, to social order, to the fundamental narrative that humanity tells itself about its place in the universe? These are not idle questions. They are the kinds of questions that intelligence agencies and policymakers think about, and the answers are not comfortable. Maybe NASA cancelled the sample return because the money was not there. Maybe Congress made a fiscal decision and nothing more. Or maybe someone looked at what Perseverance found in that ancient riverbed and decided that some rocks are better left on Mars. Either way, the result is the same. The most important scientific question in human history, are we alone, remains unanswered. The evidence sits in the Martian dust, and nobody is going to pick it up. Not because we cannot, because we choose not to. And the silence around that choice is louder than anything the instruments have detected. Chapter 12. The Great Filter. In 1950, one of the greatest physicists who ever lived sat down to lunch with colleagues at the Los Alamos National Laboratory. His name was Enrico Fermi. He had helped build the first nuclear reactor. He had worked on the Manhattan Project. He understood the scale of the universe as well as anyone alive, and over lunch, he asked a question so simple that it has haunted science for 75 years. Where is everybody? The question sounds casual. It is not. It is a mathematical knife. The universe is roughly 13.8 billion years old. There are approximately 200 billion stars in our galaxy alone. Recent estimates suggest that most of those stars have planets. Many of those planets sit in the habitable zone, the range of distances where liquid water can exist on the surface. The numbers suggest that there should be thousands, possibly millions of intelligent civilizations in our galaxy right now. Civilizations that have had billions of years more than us to develop technology, to explore, to expand. Even at speeds far below the speed of light, a civilization that started expanding 1 million years ago could have colonized the entire galaxy by now. 1 million years is nothing on cosmic timescales. And yet the universe is silent. No signals, no artifacts, no visitors, no evidence of anyone out there, anywhere, ever. This silence has a name. It is called the Fermi paradox. And the most popular explanation for that silence is the most terrifying idea in all of science. In 1996, economist Robin Hanson proposed a concept he called the Great Filter. The idea is simple. Somewhere between dead chemistry and a galaxy-spanning civilization, there is a step that is nearly impossible to pass. A filter, a barrier, something that stops civilizations from reaching the stars. The question that keeps philosophers and scientists awake at night is whether that filter is behind us or ahead of us. If the Great Filter is behind us, then we have already passed it. Maybe the jump from non-living chemistry to the first living cell is astronomically unlikely. Maybe the transition from single-celled to multicellular life is a 1 in a trillion event. Maybe the evolution of intelligence is so rare that we are the first and only civilization in the galaxy. If that is the case, we are extraordinarily lucky. The silence of the universe is explained by our own uniqueness. The filter is behind us. We have already survived it. We are rare. We are special. We might be alone, but if the Great Filter is ahead of us, the implications are catastrophic. If life arises easily, if single-celled organisms evolve on every wet, rocky planet, if multicellular life follows naturally, if intelligence is a common outcome of evolution, then the reason we do not see alien civilizations is not because they never arose, it is because they all died. Something kills civilizations after they become intelligent, something we have not faced yet. Something that is waiting for us. And this is where Mars enters the equation in the most terrifying way possible. Nick Bostrom, a philosopher at Oxford University who has spent his career studying existential risk, wrote an essay that laid this out with brutal clarity. He argued that finding simple life on Mars would be bad news. Finding complex life would be devastating news, and finding evidence of a civilization would be, in his words, by far the worst news ever printed on a newspaper cover. Why? Because every step of confirmed Mars life pushes the great filter further ahead of us. If life arises easily on Mars, then the filter is not the origin of life. We have not passed it. If complex life arises on Mars, then the filter is not the jump to multicellularity. We have not passed it. If intelligence arises on Mars, then the filter is not the evolution of consciousness. We have not passed it. And if a civilization arose on Mars and then was destroyed, then the filter is not the development of technology. It is something that happens after, something that kills civilizations that have already reached the stage we are at right now. It means intelligence is not enough. It means technology is not enough. It means building cities and developing science and understanding the universe is not enough to survive. It means whatever destroyed them is coming for us. Now, look at Earth through this lens. Our magnetic field is weakening. The South Atlantic anomaly, a region where the magnetic field is significantly thinner than the global average, is growing. Some geophysicists believe we may be heading toward a magnetic pole reversal, a period during which the magnetic shield would weaken dramatically. Pole reversals have happened hundreds of times in Earth history. During those transitions, the field can drop to as little as 10% of its normal strength. We are actively changing our atmosphere. Carbon dioxide levels are higher than they have been in at least 800,000 years. Global temperatures are rising. Ocean chemistry is shifting. The ozone layer has been damaged by industrial chemicals. We are doing to Earth's atmosphere in centuries what natural processes did to Mars over hundreds of millions of years. We are just doing it faster. Nuclear weapons exist, enough to render the surface of the planet uninhabitable multiple times over. The exact scenario Brandenburg hypothesizes for Mars is something we have built the capability to do to ourselves. And we have come close to using it more than once. Mars is not just a dead planet, it is a mirror that shows us what happens when a world loses its shield, its atmosphere, its water, its capacity to support complex life. Mars is Earth 3 billion years from now, if the Sun slowly strips our atmosphere after the magnetic field eventually fails. Or it is Earth 100 years from now, if we accelerate the process ourselves. The Great Filter does not need to be a single event. It does not need to be a war, or an asteroid, or a magnetic collapse. It can be a tendency, a pattern, a universal tendency of intelligent civilizations to develop technology faster than they develop the wisdom to survive it. Every civilization reaches for nuclear energy. Every civilization alters its atmosphere. Every civilization faces the gap between the power to destroy and the judgment to restrain. And maybe, just maybe, they all fail. The universe is not silent because no one is out there. It is silent because no one survives long enough to be heard. If Mars had a civilization, it means the Great Filter did not stop life from emerging. It did not stop intelligence from developing. It did not stop technology from advancing. It only stopped one thing: survival. And if that is the filter, if intelligence itself is what kills you, then the fact that we exist right now, in this narrow window between developing the power to destroy ourselves and not yet having done so, might be the most temporary thing in the history of the universe. Chapter 13. The Mars we are not looking for. For 50 years, we have been sending missions to Mars, orbiters, landers, rovers. We have photographed the surface at resolutions down to individual rocks. We have drilled into ancient lake beds. We have analyzed atmospheric chemistry. We have mapped the magnetic field, the gravity field, the mineral distribution, the radiation environment. We have spent billions of dollars and decades of effort. And in all of that time, every single mission has been designed to look for one thing: microbes, simple, single-celled, microbial life, not artifacts, not structures, not the remnants of something complex. Bacteria. This is not a criticism of the science. The search for microbial life on Mars is one of the most important scientific endeavors in human history. If we confirm that life arose independently on two planets in the same solar system, it means life is not a fluke. It is a tendency of the universe. That discovery alone would reshape biology, philosophy, and our understanding of our place in the cosmos. But there is a difference between looking for microbes and looking for civilization. And we have never done the second one, not once. No rover has ever been sent to Cydonia. No instrument has been specifically tasked with scanning for subsurface voids in the anomalous regions. No seismometer has been placed near the formations that Brandenburg and Hoagland and others have spent decades arguing deserve investigation. The technology exists. We have ground-penetrating radar. The MARSIS instrument on ESA Mars Express and the SHARAD instrument on NASA Mars Reconnaissance Orbiter have been mapping subsurface features for years. They have found ice deposits, layered terrain, and buried craters. The same technology could detect artificial voids, geometric patterns in bedrock, anomalous density distributions that suggest excavation rather than natural formation. We have never pointed it at Cydonia. We have seismology. NASA InSight lander proved that we can do planetary seismology on Mars. A network of seismometers spread across the Martian surface could map the subsurface in detail. Seismic waves travel differently through solid rock than through air-filled or water-filled cavities. If there are tunnels, chambers, or sealed spaces beneath the surface, seismometry would find them. We deployed one seismometer. It was placed in the flattest, most boring terrain on Mars, deliberately, because the science goal was to study the planet interior structure, not to search for artificial features. That is a valid scientific choice, but it is a choice. And the choice not to look is as significant as the choice to look would be. Japan Martian Moons Exploration Mission, known as MMX, is scheduled to launch in 2026 to study Phobos, Mars' larger moon. Phobos' surface may contain material blasted off Mars by ancient impacts, particles that were ejected from the Martian surface and captured by the moon gravity. Some of those particles may date to periods when Mars was habitable. MMX will collect samples from Phobos and return them to Earth. This is exciting science. But MMX is not designed to look for civilization evidence. It is designed to study geology. China, Tianwen. 3 mission aims for a 2028 launch, with sample return by 2031. But it will collect samples from a different location than where Perseverance is working. The Cheyava Falls sample, the one with the potential biosignature published in Nature, will remain on Mars, unretrieved, unanalyzed by Earth-based laboratories, sitting in its titanium tube in the dust of Jezero Crater, the most important rock in scientific history, stranded. And here is the systemic problem. SETI, the search for extraterrestrial intelligence, has spent over 60 years listening for radio signals from distant stars, billions of dollars, thousands of hours of telescope time, all pointed outward at the sky. The assumption underlying SETI is that intelligent life, if it exists, is far away, light years distant, in other star systems, around other stars. But what if the nearest evidence of intelligence is not light years away? What if it is 55 million kilometers away, sitting on the surface of the planet next door? What if we have been pointing our telescopes at the wrong target for 60 years? The institutional barriers to asking this question are enormous. No career in planetary science survives association with the word artifact. Any researcher who proposes investigating anomalous Mars features for signs of artificiality risks being lumped in with UFO enthusiasts, conspiracy theorists, and pseudoscientists. The professional cost is total. Funding disappears. Publication opportunities vanish. Colleagues distance themselves. Careers end. And so the most scientifically important question in human history, are we alone, is being answered by missions designed to find bacteria, while potential evidence of something far more complex sits on the surface of Mars, deliberately uninvestigated. A simple rover mission to Cydonia with a mass spectrometer could settle the Xenon-129 question within weeks. Is the isotopic anomaly real at ground level? Is it localized? Does it match nuclear fission signatures when measured directly rather than from orbit? The mission would cost a fraction of what the cancelled Mars sample return would have cost. It would answer one of the most provocative questions in planetary science. And nobody has proposed it. Not because the science is not there, because the question is too dangerous. Because the answer might change everything. And because institutions, even scientific ones, are built to produce the answers they are designed to find, not the answers that would force them to redesign themselves. We have the technology to answer this question. We have the missions, we have the data, we have everything except the willingness to look, not because we cannot, because we are afraid of what we might find. And while we hesitate, while we debate budgets and manage perceptions and protect careers, the face sits in Cydonia. The Xenon-129 sits in the atmosphere. The Cheyava Falls sample sits in the dust. And nobody goes to look. Chapter 14. The Mirror on Mars. We have come a long way tonight, from a rock in a dry riverbed to the oldest stories ever written by human hands. From biosignatures sealed in titanium to isotopes that match nuclear test sites. From a face on a mesa to a gas that breathes in the dark. And now we are here, at the end, at the question that everything has been building toward. The question that does not need Mars to be real. The question that matters, whether or not a single organism ever lived on that red dust. The question is this: what are we looking at when we look at Mars? Every piece of evidence we have discussed tonight, the lost atmosphere, the dried oceans, the dead magnetic field, the surface radiation, the underground water that once flowed freely on the surface, but now hides in cracks in the rock. Every single piece of it describes a process that is physically possible on Earth. Not in theory, in practice. Earth's magnetic field has reversed hundreds of times in its history. During each reversal, the field weakens dramatically. For centuries or millennia, the shield that protects us from the solar wind drops to a fraction of its normal strength. During those windows, atmospheric loss increases. Radiation at the surface increases. The protection that makes complex life possible on Earth surface thins. We are not immune to what happened to Mars. We are simply younger. We have not run out of core heat yet. We have not lost enough internal energy for our dynamo to die. But we will. Billions of years from now, Earth core will cool. The dynamo will slow. The magnetic field will weaken and eventually fail. And when it does, the same process that stripped Mars' atmosphere will begin on Earth. The solar wind will tear away our air molecule by molecule. The oceans will evaporate. The surface will be sterilized. Everything we built, everything we loved, everything we were, will be erased. That is billions of years away. We have time. But here is the part that should not let you sleep, even though that is what this documentary is designed to do. We are not waiting for the natural process. We are accelerating it. Carbon dioxide in Earth's atmosphere is higher now than at any point in at least 800,000 years. We know this from ice cores, from isotopic analysis, from the same tools we use to study ancient Mars. We are changing the composition of our atmosphere in real time. We are warming the planet. We are acidifying the oceans. We are thinning the ozone layer. We are doing in 2 centuries what natural processes did to Mars over hundreds of millions of years. We are just doing it faster, and we have nuclear weapons, enough to render the surface uninhabitable. The exact scenario that Brandenburg hypothesizes for Mars is something we have already built the capability to execute. We came close during the Cuban Missile Crisis. We came close during the Able Archer exercise in 1983. We have come close dozens of times that the public does not know about. If Mars had a civilization, it faced everything we face: resource depletion, environmental degradation, possibly conflict, and it lost. The planet that was once Earth twin is now a frozen desert where the air is too thin to breathe and the radiation would kill you in hours. That is what losing looks like. And the most chilling implication of the Great Filter is this: intelligence might be common in the universe, but long-term survival might be vanishingly rare. Every civilization might reach a technological threshold, a point where its power to alter its own world exceeds its wisdom to manage that power, and fail. Every civilization develops energy, technology. Every civilization alters its atmosphere. Every civilization faces the gap between what it can do and what it should do. And maybe they all fall into that gap. The universe is not silent because no one is out there. It is silent because no one survives long enough to speak. Earth has existed for 4.5 billion years. Human civilization has existed for roughly 10,000. Industrial civilization for about 250. Nuclear capability for 80. We have been advanced for less than 1/millionth of 1% of Earth history. A blink. A fraction of a fraction of a fraction. And in that blink, we have already changed the atmosphere, damaged the ozone, warmed the climate, built weapons capable of ending everything, and begun the process of altering our planet in ways that echo what happened to Mars. If a Martian civilization existed, it lasted longer than we have, and it still was not enough. Now, we may never know for certain whether Mars had a civilization. The evidence is suggestive, but not conclusive. The science is extraordinary, but incomplete. The conspiracy theories are wild, but not entirely without foundation. What we know for certain is this: Mars was habitable. Mars had water, organic chemistry, energy, and time. Mars has anomalous surface features that have never been investigated at ground level. Mars has unexplained isotopic ratios in its atmosphere. Mars has methane that behaves like a biological signal. Mars has a biosignature sealed in a titanium tube that nobody is going to retrieve. If all of this adds up to just geology, just coincidence, just pareidolia and instrument error and natural volcanic chemistry, then we should feel relieved. But if even one piece of this puzzle turns out to be something more, if the biosignature is real, if the methane is biological, if the isotopes are not natural, if the shapes on the surface are not just mesas, then Mars is not just a dead planet. It is a tombstone, and the epitaph is written in a language we are only beginning to learn how to read. The Sumerians, the first civilization, called their gods those who from heaven to earth came. The planet those beings may have come from is visible on any clear night. A red dot in the sky, small, quiet, patient. We named it after the god of war. Maybe we should have named it after the god of warnings, because Mars is not just a planet, it is a message. A message written in dried oceans and thinned atmosphere and buried water and silence. A message that says, this is what happens when a world runs out of time. We are not running out of time yet. But the clock is ticking, and the mirror on Mars, the red mirror that shows us our possible future, is there for anyone who cares to look. The question is whether we are willing to see what it shows us, and whether we are wise enough to choose a different ending. If you enjoyed this journey into the mysteries of Mars and what they mean for our own future, please like this video and subscribe to the channel. Your support makes these long-form investigations possible. Tell us in the comments, do you think Mars once hosted more than microbes? Do you think the Cheyava Falls sample should be brought home? And do you think we are paying enough attention to what the red planet is trying to tell us? These are not just questions for scientists, they are questions for all of us. Because the past is not a closed book. It is an open dig, and the most important discovery might be the one we are too afraid to make. Thank you for watching. I will see you in the next investigation.